In this video on Objective 3.5, we'll find the perimeter and area of compound shapes using known properties of simpler shapes. In this first example on the left, this shape is made up of rectangles. And we're going to need to know this dimension and this dimension to enable us to find the perimeter. So, to find the horizontal distance there, we can look at the total horizontal distance from one end to the other is 10 centimeters. So if this part here is 6 centimeters, we'll need another 4 centimeters up here. And then we can look at the vertical distance to help us get the other dimension. If this full vertical distance is 9 centimeters and there are only 2 centimeters here, that means this piece has to be 7 centimeters. 2 plus 7 is 9. Okay, so we have everything we need for perimeter. Perimeter, I'm going to start at this corner here and just walk clockwise. I've got 4 centimeters plus 7 centimeters plus 6 plus 2 plus 10 and 9. So the perimeter of this rectangular shape is 4 plus 7, 11, plus 6, 17, 2, 19, 29, 38, and the units were centimeters. Now when it comes to finding area, the trick is to break the shape into maybe 2 or more figures for which you know the area formula. I mean, there is no such formula for this weird looking L shape, but if we break this L shape into 2 rectangles, we definitely can find the area now. So there's this rectangle here that has an area of length 10 times width 2, 10 times 2, and then there's another rectangle up here. This rectangle has a dimension of 4 by 7. It's a 4 by 7. So one dimension is 4 and the other dimension is 7. So the area is the sum of the 2 rectangles. We've got 20 plus 28. So area is a total of 48. And it was centimeters times centimeters. So it's centimeters squared. In the next figure, we've got, looks like a trapezoid. It's a trapezoid that's not resting on its base. This one's fairly complicated because I can't use rectangles to help me find this mystery dimension. But what I can do is I can create a rectangle. Let's see if I can draw it. Pretend that's a rectangle. And in that case, if this is 5, then this dimension here is also 5 centimeters. So I've got a 7 by 5 by 7 by 5 rectangle, leaving exactly 1 centimeter here. Because if this is the total distance was 6 and that piece is 5, that means this one little piece is 1 centimeter. So now, to find this mystery dimension, here, I'm going to go ahead and sketch this over here. I'm turning it kind of right side up. Here's this 1 centimeter dimension. And this long piece, this 7 centimeter piece, could be over here. So now I'm going to use Pythagorean theorem to find the hypotenuse of that right triangle. 1 centimeter squared plus 7 centimeters squared equals this hypotenuse squared. So I've got 1 centimeter squared plus 49 centimeters squared equals the hypotenuse squared. I'll call it c squared now. So we've got 50 centimeters squared equals c squared. So I'll have to take the square root of both sides. And the square root of 50 can be simplified. 50 can be thought of as 25 times 2. The square root of 25 is 5. So it becomes 5 square roots of 2. And centimeters squared, when you take the square root of centimeters squared, you get centimeters. And over on this side I have c. So I've now found this dimension here. This dimension is 5 square roots of 2 centimeters. So the perimeter is, I'll start up here, 5 square roots of 2 plus 5 centimeters plus 7 centimeters plus 6 centimeters. And the 5 square roots of 2 and the integers cannot combine because these are irrational and these are rational. So we'll get 5 plus 7 is 12 plus 16. 18 plus 5 square roots of 2 centimeters. That's the perimeter. Now the area is much easier because this is a trapezoid. So we can use what we know about the area of a trapezoid. Area of a trapezoid, you add the bases together. The bases are the 2 parallel sides. So we've got 6 plus 5 all over 2 times the height of 7. So 6 plus 5 is 11 divided by 2 times 7. 11 over 2. I'm going to write that as 77 over 2, and that will be centimeters squared. 77 over 2 centimeters squared. And this last figure is interesting looking. What kind of shapes is it made of? It looks a little bit like maybe a square or something. And somebody cut out these quarters of the circle. That's exactly how we're going to approach it for area. But first, let's do perimeter. So we know perimeter is just the sum of all the distances around it. And these are the easy ones. These are all 4 meters. So those pieces won't be too hard. Perimeter will be 4 times 4 meters. Plus, we also need to find these dimensions. Let's see. Oh, good. I can highlight them. We need these little pieces also. Now, in this figure, those little pieces, those are indeed quarters of circles, and there's 4 of them. So the sum of all of these yellow portions is just the circumference of a circle. What kind of circle? Well, this tells us it's a circle with radius equals 5 meters. So the circumference of a circle with a radius of 5 meters is 2 times pi times 5 meters. So apparently the full perimeter of this shape, summing up all the outer edges, is 16 meters plus 2 times 5 times pi, 10 pi meters. So that's the perimeter. You get the 16 meters from the segments that are 4 meters each, and you get the 10 pi meters from the curved portions that together make up one complete circle. So for area, we're going to use the idea that I alluded to before. You can think of this weird shape as a square, and somebody's cut out 4 quarters of a circle. So the area of the shape of this weird shape is basically the area of a square minus the area of a circle. So I'll go ahead and write that. Area of a square minus the area of a circle. So this square has side lengths of 5 meters, 4, and 5. So it's 10 plus 14 meters. And you know, when we find the area of a square, we take one of the sides and we just multiply it by itself. The area is 14 meters times 14 meters, basically base times height. The area of a square is the side length squared minus the area of the circle, which is pi times radius squared. Well, the radius is 5 meters, and we have to square it. So let me see if I can find some room. I guess not. So the area of this shape is going to be 196 meters squared, which is 14 squared, minus 5 squared is 25, minus 25 pi meters squared.